Hey guys, welcome back. I have something cool to share this episode. During my research, I ran across, his name is MuttStang. I reached out to him and he sold me his project. Basically, he's doing the same thing that we're trying to do here. Remote control, console unit, and he just didn't have time to completely finish the project, but he got to a certain point where I think, we're gonna take some of his ideas, put it into our design. I'm gonna examine everything here. I'm gonna show you what he sent me. So again, we'll break that into these pieces here. Let's go over what he sent over in his project. So he sent over his remote here, and then the base unit, console unit to communicate with the main motor. He sent two modules, our compass modules, and he 3D printed these enclosures for the compasses. And he had already started on the compass heading, and he used two Bosch BNO 055 sensors here, and these will act as our heading sensors. He has one for the motor, which way that's facing, and one for the boat. He also sent a GPS antenna right here. This is a magnetic base. This one is a Talisman 33241200-1000. We'll stick with this hardware as well. And let's go ahead and kind of do a tear apart of the system here and just do a little examination. I'm going to link his GitHub project in the description, so you'll be able to review that, see some of his files. He has some diagrams on there that you can do more of a review. So let's go ahead and tear this thing apart. So in the console unit, it looks like he was going to do a menu with the LED screen here. He has up and down, exit, and menu. And then it looks like he made a custom PCB board. In here, he has his 3 relays, very similar to our design. He has connections here that are for the buttons on these buttons up here. He did not have those hooked up yet. And then he has a power button here as well. Those weren't hooked up. And then he has his charger cable for the remote. So we can take that apart and see what we have here. And again, here's kind of the PCB. He has his inputs on these connectors here, his 3 relays here. He does have a resistor network here, a potentiometer network here that's not really being used. I asked him about it. He said he's just doing it for testing purposes. And then he has a port here for the compasses. And then on the back side, he has his resistors and diodes and stuff for safety circuitry. Next, that we pull out, this is for the GPS unit. This is a Adafruit Ultimate GPS plus logging shield. Basically plugs into our ESP32 Metro board to receive the information and to be able to use that in our project. And then lastly, he has his Adafruit Metro ESP32 S2 Express beta board in here, and that is the brains of the console. Next, let's take apart the remote. On his remote, he has a toggle switch here to turn on and off the remote. He has a power button to turn on and off the motor, the navigation button to go into navigation mode, manual mode, speed up, speed down, steering left and steering right, and then he has an anchor mode as well. So we take it apart, and you can see the mechanical buttons here, and LED screen as well. His charging port is here. And then we can get this unscrewed. So again, he's using a custom PCB board. He did send me a few extra of the boards, so I'm able to look at those and kind of use that as a reference as well. On the remote, he's using let's take this out. He's using a Adafruit ESP32S2 Feather, 240 megahertz, 4 megabytes of flash, and 2 megabytes of PS RAM. So this thing's pretty tiny. And then his custom PCB board, again, has your buttons, has some connections here for the battery charging. The battery's behind the screen. I'm not going to take apart the screen. And then he has this 1.5 OLED module here. So let's get this thing put back together. Let's see how it works. See some of the features he put in here. And then we're going to talk about some of his design. We're going to talk about his design and if there's some improvements we can make to it. Okay, I have the system put back together. I have it powered up. And on his LED screen, he's outputting lat and longitude, what mode the controller's in. Right now it's a manual. He has a power output, and then the boat and motor headings in there, and a PID section. I'm not sure what that's really outputting right now. And then with the remote, I'll turn that on. As you can see here, turns on the LED screen. It's communicating some information. Again, it tells you what mode you're in. We're in manual mode. Has a little battery meter here, showing how much battery's left in the remote. And then he actually built a compass that gives you the motor heading for both the boat and motor. And then it says if the motor's on and off, speed, and that type of stuff. So let's see how this works. I'm going to hit the power button. I can hear the power relay starting. I can hear it turning off. Let's go speed up, and then it actually changes the speed here. It looks like it goes up by one tenth of a mile per hour, and then left and right. I can hear the relay clicking there, and then relay right. Yep, same thing. And then navigation mode, just changes the modes right now. Yeah, so it looks like, he got pretty far in this project. I'm going to do some analysis of the circuitry and try to understand the project a little bit more. Let's go ahead and do that. Let's talk about the design of MuttStang's project here. I think he did an awesome job. It looks like it's fully functioning. I might try this out on the boat, see how it works, make sure everything works okay, and then we'll go from there. So let's talk about some of the things that I found while reviewing the design. I think the remote works perfectly. I'm not going to change the design of this at all besides the software side of things. I'll probably change his coding will be on the GitHub page for you to review if you want. Let's talk about the console unit. So in the console unit, what he's doing here is he's using the 12-volt rail from the trolling motor to power the ESP32. What I found out was you can do that because you can do a 12 volts input into the barrel jack, and it will convert the power down to two sources, a 5-volt rail for your 5 volts on the ESP32 board as a voltage out, and then it converts it further down to 3.3 volts to power everything else with the ESP32 chip and your 3.3 GPIO ports. One problem that I know, one issue that I have is that The Adafruit ESP32 voltage regulator is a linear voltage regulator. So it's taking that 12 volts, dropping it down to 5 volts, and a linear voltage regulator is inefficient when it does that. And what happens is when you're dropping that voltage, it's output as direct heat. Or if we look at it, we're dropping by 7 volts, which is then output by heat. There's formulas out there that we can use depending on how much current draw we're using as well. But I was estimating between 1 to 2 watts of heat into that voltage regulator. And if we're in that boating environment, if it's in an enclosed enclosure, all that heat is pretty much trapped in here. What I'd like to do is change that design so the linear voltage regulator isn't pushed as hard. And I'm going to probably input less voltage. So I'm going to take that 12 volts, use a buck converter, which is much more efficient, and then drop that down to probably like 6 or 7 volts. So that linear voltage regulator doesn't have to drop as much, and we don't have as much heat output and putting so much stress on that voltage regulator, and maybe even burning it out in long-term use. Another thing I could consider doing is adding a fan or something in here, but there's not a lot of space for that. He does have like a little port here to access the ESP32 stuff. Might be worth keeping that open just to let heat escape or while I'm running the controller. Another thing I was looking at is the design of the relays. So the way this works right now is he's using the GPIO ports to control the relays directly, sending 3.3 volts to the coils, which can create a lot of current for the ESP32 ports. And what I did was I looked up the data sheet for these relays, and for the 3 volt version, we're looking at a resistance of 64.3 ohms. And using Ohm's law, I calculated that each GPIO port at 3.3 volts is using about 51.32 milliamps. And that's beyond the capacity of what most people say of what the GPIO ports should be running at a time. The upper limit that I saw was 40 milliamps, but most people usually recommend 20 milliamps. So to compare the design, looking how relay modules work, they have extra components here, and they're using either a MOSFET or transistor to control the relay itself. And that way you're not using as much current to drive the relay to open and close. So they're not directly driving that. And that's why with these relay modules, you'll usually have a GPI input, but you'll also have an external power requirement there as well. So I think in the long term, if you were to use it directly the way it is, it would eventually damage the ESP32 board. And we're looking, you're looking at an extra 10 milliamps. And if you're running it the whole time, let's just say you have your motor on the whole time, you're running that pin at over capacity for a long period of time. And I think eventually you'll damage the board. So we'll have to look at how to design our own kind of relay module using MOSFETs to solve that issue. I did forget to mention on this board, he does have his speed controller on here, an IC potentiometer, and he's using the I2C interface to control it. I'm probably gonna do something similar to that, and I'll probably use the exact same digipot. And as you can see, these things are very small. And he's using an AD5247 digipot here, just for your reference. Oh, one thing with the remote that I forgot to mention, it does have a charging port at the bottom. He's using these connection pins here, and he's able to charge it up with this port here with a 5 volt output. One thing that I would change on this, which I probably won't because I don't have a 3D printer to change this port or anything to design it better, is if I want to upload code to this, I actually have to take it apart and get to the USB-C port of the ESP32, and it's kind of a hassle. The way I would do is just use the USB-C port here and then just charge it remote where I don't have a base for it. And that would also shrink this a little bit. But again, it's not that big of a deal. I don't have a 3D printer, so I'm just probably going to keep it the way it is. So what I'm going to do is I'm going to hook this up to the boat, just demonstrate that it works. I don't think I'm going to take this out on the water just because of those issues that I pointed out earlier. The voltage regulator as well as overdriving the GPIO pins. I think a lot of things in here I'm going to use. I'm going to use a lot of his ideas, do some refinement. I'm going to design my own code to control the different modes. So let's go ahead and bring this out to the boat, do a little testing, see how it works, but I'm not going to use this as a long-term solution. All right, we're in the garage. We are set up. As you can see, it does power on from the motor with that 12 volts. Motor's on. Turn on the controller. And then we will try the steering. Steering looks like it works. Let's turn on the motor. Maybe we didn't hook up the potentiometer correctly, but it was working earlier. I know it worked. We'll have to play around with it a little bit more. Oof. Yep, it works. Let me move this up so we can see the motor actually turning on. Alright, let's go ahead and turn on. Motor works. For some reason our speed control is not working, but I'll have to mess with that. It's not a big deal. Not a big deal right now. Okay, so his power on the remote is for the power. His power in the corner is for how fast the motor's going. Same with the console. It's kind of cool. I don't want to take it apart again to prove it works, but I know how the logic works, so it should work okay. Let's go ahead and turn off the power. All right, let's go back to the office and do a little discussion, and we will talk about what we're going to do for the next steps. Back in the office, I did try to get the speed control work, troubleshoot it a little bit. I didn't play around too long since I'm going to redesign it anyways. I know you can control it through a digipod, so I'm not too worried about it. I don't know if that's something in the software that needs to be changed or something in the hardware that I won't be able to fix on this. So overall, I mean, this is a great first step for me to get some design ideas, look at the software and get that information. The heading, I did try the heading modules, they work. I also did the GPS, that worked. I don't want to give my GPS coordinates out, but I will demonstrate the heading information. Let's plug that in. Plug in the heading modules just so you can see it working. You can see right now we have two different readings on our boat and motor headings. But if I start moving this, it should, yep. So if I rotate it, it's starting to change our heading. So that one works. Let's see what happens with the motor. Oh, sorry, I'll do this again so you guys can see. Try to get close up. Okay, the other one does the same thing. There we go. With his project, I got a lot of ideas. He's done a lot of work for me. I don't need to research too much into the compasses. I think these will work great. I don't need to worry about the GPS information, do the software side. But overall, this project works perfect with just some little design decisions that I want to change. With that design decision, the problem for me is I'm going to have to create a custom PCB board as well to fit on top. And I was planning on doing that anyways because I wanted to look professional. But as far as the guts of this project, I mean, I'm going to keep the remote. I'm going to keep this box. I'm going to use the GPS logger. I'm going to use the compasses and the GPS hardware. The only thing I'm really going to change is just kind of the design of his custom PCB with especially the relays, and then trying to figure out how to create a buck converter to drop voltage without that heat issue. I'm going to also think about maybe adding a fan or more ventilation holes into this thing. I know in the boat environment we're going to have water, so that's something else to consider. He thought ahead and has some additional features in here with the menu buttons, being able to pick different options, I'm guessing. I'll just keep the buttons on there, but right now, we don't need to code anything. My next step is to use the hardware I looked at buying last time. I bought the ESP32 Feather and then ESP S3 Metro board as well. I'll be able to kind of mimic what he has here and then go into designing the relay controls using those MOSFETs or transistors to control the coils versus going directly to the coil and using the higher current that might damage the board. I did do some math here as well for total amp usage. Right now, this design is using about 51 milliamps of current for the relays. The GPS data logger has 30 milliamps at max. The Talisman GPS, the GPS unit module uses 12 milliamps. Each one of these BNOs uses about 14 milliamps at max, times 2 is 28 total. And then the Feather OLED, this screen here uses 30 milliamps max as well. And then there's probably just a little bit of milliamps to run the charger. So at max, we can be using, so we're looking at about 202 milliamps for this design. It looks like we can use about 400 to 500 milliamps for a ESP32, so we're good there. The big thing is just trying to lower that relay milliamps per GPIO. So we'll look into doing that and creating a prototype for our circuit. Thanks for tuning in. Like I said, this design will be on MuttStang's GitHub, so you can look at that. I'm going to work on my design now, create a prototype, and I'll see you guys next time. Thanks.